These are the solutions to homework 1.1, which is on significant digits and units. The first question, number 1, your book uses MKS units, which are also called SI units. What does MKS stand for? I'm not sure it's actually explicitly written in your book, but this is meters, kilograms, and seconds. And practically every calculation we perform will use some combination of them or units derived from them. But it's important to remember that although grams is the base unit of mass, we don't use that in many calculations, and pretty much figure none unless it explicitly says in grams. On to number 2, list the number of significant digits. 2.43, well, that's an easy one, we can count all of them. B here, 0.0778, we have to use one of the rules that says any leading zeros, ignore. So we ignore the 0 and the 0, count just 778, which is 3. C, we have to use another rule. Any following digits without a decimal place, any following zeros without a decimal place are not counted. So the 0, 0, and 600 are not counted, only the 6s. In D, though, once we put that decimal place in there, trailing zeros become significant. So we have to count all 4 of those zeros plus the 6, so that's 5. E, we kind of combine them. This leading 0 we don't count, but the 2 trailing zeros we do. Those add precision to our numbers. So we have 1, 2, 3, and 0, 0 for a total of 5 numbers. And again, F is an easy one. Count all 3 of them. 3, adding and subtracting. Remember the rule here is that you count up the number with the fewest number of decimal places in whatever constituents you have, and you use that fewest number, so you have to round after you add them. So number 3, 60 has 0 decimal places, so we know our answer has to have 0. So 60 plus 7.25 is 67.25. We have to round to 0 decimal places, which gives us 67. 17.8 minus 1.25 would give us 16.55. We have to round that to 1 decimal place because of the 0.8 here. So that's 16.6. C, when we add these two, we get 13.01. But because we have 0.007, 0.003, we need 3 decimal places in our result, so we need to add an extra 0 at the end, so it's 13.010. Likewise here, we have 4 decimal places in our first digit, 4 in our second, so we need 4 in the answer. We're not rounding because this one has 2 significant digits, and this has only 1. We're keeping the same number of decimal places. On to number 4, multiply or divide. Here, we do count significant digits, and our answer must have the same number of significant digits as the fewest in any of the constituents. 60 has only 1 significant digit. We have 3 significant digits here, but 60 times that means we have to have 1 in our answer. So I think it works out to 435, but we have to round that back to 1 significant digit, so drop those last 2, round it down to 400. B, I'm going to have to get the calculator for this one. 17.8, that has 3 significant digits. 1.25 has 3, so our answer can have 3. Dividing those straight gives us 14.24, but rounding it off to 3 decimal places gives us 14.2. We have 5 decimal places in our first number in C, 4 in our second, so we can only have 4 in our solution, and when you plug this into your calculator, you get 11.9710867.4. We have to round that back to 4 significant digits to match the 1.003. That rounds to 11.97. D, there are a couple ways you can write this. We have 2 significant digits in this number, 2 here. Sorry, 1 on that second one. When we multiply them together, we get 4.38 times 10 to the negative 6. So we could write it either as, rounding it down to one significant digit, 4 times 10 to the negative 6, or you could write it out 0.000004 would be okay too. 5 deals with conversions, just to get you back in the habit of using metric system. 25 centimeters into meters. For all of these, even to this day, I almost always write it out using the dimensional analysis techniques, which we will practice in a future homework. But just to show you how it goes, start out with 25 centimeters. I know that in every 1 meter there are 100 centimeters, so I get 0.25 meters. 13.7 kilometers into centimeters. Start out with my 13.7 kilometers. I know there are 1,000 meters in 1 kilometer and 100 centimeters in 1 meter. Multiplying those out, I get 1.37 times 10 to the 6 centimeters. 12 millimeters into kilometers. Down here, I'm going to meters first. I know in every meter there's 1,000 millimeters. Every kilometer there's 1,000 meters. So that winds up being 1.2 times 10 to the negative 5 kilometers. And finally, 0.073 meters into centimeters. Down here, start out with my meters. I know there are 100 centimeters in every meter. Gives me 7.3 centimeters. 6, we're converting in all of these into kilograms and writing them in scientific notation. The 1,075 kilograms, that's pretty easy. Just slide your decimal place over. It's 1.075 times 10 to the 3. 88 grams, I'm going to use dimensional analysis again. I know that there are, in 1 kilogram there are 1,000 grams, so I get 0.088 kilograms, and converting that, I slide that over 2 in the negative direction, so 8.8 times 10 to the negative 2 kilograms. 677 milligrams. I know there are 1,000 milligrams in a gram, 1,000 grams in a kilogram. That winds up being 6.77 times 10 to the negative 4 kilograms. Finally, picograms. Picogram, there are 10 to the 12. What is that, a billion? No. Trillion. It's 10 to the 12. Picograms in a gram. Much easier to remember than the name. And 1,000 grams in 1 kilogram. So this ends up being very tiny, 5.43 times 10 to the negative 13 kilograms. Last one, perform the math operation on this sheet, I should say. Perform the math operation indicated below. Report the answer in scientific notation. 8.17 times 10 to the 7, that has 3 significant digits. Remember to use your double E, that second function, and the comma. It's not as important when you're multiplying these numbers, but it's extremely important when you're dividing them. Times 1.1 times 10 to the 4, and just to remind you, here's what that should look like when you're done. 8.987 times 10 to the 11, but we only have 2 significant digits in the 1.1, so we have to round that off to 9.0 times 10 to the 11. Next one, 4.223 times 10 to the 10th times 8.881 times 10 to the 10 squared. We have 4 significant digits in each. Nope. So our answer will have 4. Multiplying those together, 3.75044 times 10 to the 13 rounds back to 3.750 times 10 to the 13. Next one, 1.23 times 10 to the 6 divided by 5.4 times 10 to the negative 3 is 2.277, repeating, times 10 to the 8, and since there are only 2 significant digits here, we have to round that to 2.3 times 10 to the 8. Now let me show you what I meant earlier. Here's our answer as is, but if I put this in as a lot of people tend to, 6 divided by, and I don't put the parentheses around, I get a very different answer. 227. Now if you put parentheses around 5.4 and the end parentheses here, you would get the same answer as I got above, which is correct. But I feel that this e, which is the second function, and the comma, is a lot easier to use, a lot easier to remember. The last one, 5.4 times 10 to the negative 4 divided by 4.667 times 10 to the negative 3. We have two significant digits in this 5.4, so we should have 2 in the end. Comes up, and my calculator is 0.1157. I have to round that to two significant digits, which would be 0.12, and in scientific notation, that 0.12 becomes 1.2 times 10 to the minus 1. On to the back. Measurements, I'll leave it to you to verify these. I got 5.61 centimeters for the length, 2.55 centimeters for the depth, and 3.60 centimeters for the height. Now if I do the calculate the area, that's going to, and I mean just the area of this front face, that'll be 5.67 centimeters times 3.80 centimeters. Both of those have three significant digits, so that's what my answer has. So I get 21.3 centimeters. It's squared. Importantly, always keep units. Whenever there are units, keep them there. The volume, I take that number basically, multiply those two, and multiply it by my 2.55 centimeters, and again, three significant digits. I get 54.4 cubic centimeters. My thermometers. Remember that you can add one dimension or one kind of tick on the scale and use that as an estimate. On this first one, for 9, I go 40 to 45 to 50. All I can add is a single, a ones digit in here. So this looks to be pretty much in the middle. So I could say either 42 or 43 and be correct. But I could not say 42.5 because I can't add that 10th digit. On the next one, though, now I can see it's about halfway in between the 42 here and the 43 there, so I can say 42.5 on this one and be correct.